Hey, I want to talk about one of my favorite functions in JavaScript, and that is the reduce function. If you ever try to do functional programming in JavaScript, this is a very useful function along with .map and .filter for doing data transformations. And even if you're not doing functional programming, it's still useful anywhere you need to transform data from one kind of format into another. There's all kinds of use cases even outside of data transformation, which we'll try to touch on here. So let's just dive right into it. Reduce is a function on the array prototype in JavaScript. So any array can have reduce called on it. And really what it does is it takes an array of items. So we have some things in an array here, and it transforms them into kind of a single item. And so there's a lot of applications for that, and really the most basic one I can think of for a starting example is summing the values in an array. So if I have some array that looks something like this, maybe the numbers 1 through 5, and I want to get the sum of that, which is going to end up equaling kind of 15 if we do it correctly, then what I really want to do is go through this array, right, and transform it into a single value. So it's the perfect example of reducing a bunch of items into one single value. So let's just code that out with reduce, and I'll kind of explain how the reduce function works. So reduce, again, starts with the array, and you can call reduce directly on it since it's an array in JavaScript. And it's going to take two parameters. The first one is a function that it's going to execute with every single item in the array to figure out how does it combine these together into that final value. So we'll have some sort of function here. And what that function needs to do is return a value for the next step in the array. The idea is that this reduce function is going to run this function for every single item, and along the way is going to be keeping track of what you're returning and passing it to the next one, so that at the end of the day, the end of this loop, when you pass the final item, that is the final value. So we'll want to keep track of that. And so what we can put into our function is really two parameters coming in. The first is sometimes called the accumulator, and that's kind of the value that's being passed from iteration to iteration. So it's kind of our running value, or in the case of a sum function, it's going to be our running total. The second value in the function is going to be the actual current value we're looking at in the array. So we'll just call this cur for current. So for every item in this array, we'll run this function once for the value 1, then for the value 2, for the value 3, 4, and 5, etc. Finally, we need to give it a starting point. So in the case of a summation function, we really want to start at 0. If we haven't summed anything, then our value is just going to be 0. And that ends up being the second parameter in our sum function, is this 0 value. So now all we need to do is kind of fill out what is our method for reduction. What do we do with each item coming in? What does it do with that 0? So the first time this runs, 0 is the accumulated value. So we'll have the value 0 coming in, and then we'll have the value for cur being 1, which is the first item in the array. So what do we want to do with 0 and 1? Well, what we want to do is we want to add them together. So that's really our reduction here, is that for every single value coming in, every current value, we want to add it to the previously returned value, which in this case is the accumulator. So what this will do is, as we run this, it'll start at 0 and then get 1, and we'll have 0 plus 1 equals 1. Then it'll run this function again for the value 2, where 2 is the current value, and 1 is the accumulated value that was received before, etc. And that's pretty much it. So we can console out this sum, see that it's working. I just have a terminal right here. I'll just run the function, and there's the value 15. So again, the code for this is you call reduce, you give it some function with the accumulated value plus the current value you're looking at that returns something that tells it what to pass as the next accumulated value, and then you can give it a seed as a starting point. To make this a little more straightforward, I have an animation I produced to show this exact code block in action. So let's say this is my array of items, 1, 2, 3, 4, and 5. Here's my reduction function. I'm going to look at the accumulated value and the current value, and I'm going to return the summation of those. And then here's my accumulated value, which is 0. And we can just step through this one at a time. So in the first iteration of reduce, it's going to take the 1 value, it's going to bring it down, and it's going to add it to the accumulated value. So now the accumulated value is 1, so it's 0 plus 1. On the next iteration, it takes the second value, pulls it out, adds it to the first value. So now the accumulated value is 3. The next iteration of the function, 3 is the current value, 3 was the accumulated value, so you add them together, you get 6, etc. 4 comes down, 6 plus 4 is 10, and finally you do 5. 10 plus 5 is 15. So great, this is how you do a simple sum in the reducer with that all working. So let's try another function. Let's do a multiplication function. So we'll just copy paste this. Say, what if we want to multiply everything in this array? So we'll call this mult, and instead of adding these together, we'll just multiply them together. And if we run this, what we're going to see is that we actually end up getting a 0 out, which is not the value we wanted. So why did we get a 0 out? Because we have 0 as a seed value, and so if you start multiplying every number by 0, then you're always going to get 0. So this is really the wrong seed. So there's two things we can do here. First thing we could do is just change the seed to 1, and so that way that kind of first seed value is not really having any effect. However, we don't actually need to use a seed. So if you have a situation where you don't need a seed, like we want to multiply these numbers together, there doesn't need to be some pre-starting point, we can actually just remove the seed, and it will use the first value of the array as the seed. So in this case, we're multiplying numbers together, so we really can just use the values in the array to produce this. And now if I run this again, I'll get 120. And you can see if I were to change this, like let's make this 10 instead of 1, then I'm going to get the result of that, 1200 instead. So these are simple examples of using reducers to just take a set of numbers and then transform them into a single number. It's very useful, but you can do more advanced things. So I'm going to jump ahead to a common use case I see when working with APIs for things like data retrievals from servers. So when we're retrieving data from servers, usually it's an asynchronous operation, over some sort of network call, and that ends up giving us being programmed in the form of a promise, right? Because we need to tell the JavaScript environment, hey, we have this async code running, and when this result happens, we'll get this value back. So let's just mock up an example kind of data call, an Ajax API call. We'll make a function called get, we'll call it make API call, and it'll just like take an ID or something like that, and we're kind of faking that we're getting this data set right, so we're just gonna make up an asynchronous function. We're going to say return a promise, and in that promise we'll give it like a timeout where it will resolve with just like the same ID. So it's kind of like we're gonna ping it with this ID and kind of fake that we get the result back, and we'll just give it like a 1 second delay, right? So if we just test our API call to make sure it's working, let's do something like make API call. We'll do the value 1, and then we should do a dot then, and we say when our value comes back. In fact, here, make this a little more concise. We'll just log out the value that comes back. And I'll also console.log just like the start point here so that we can see like the 1 second delay for our response. So if we run our script, we get a start, you wait a second, then it kind of responds with the value 1 back, right? So it kind of made this fake API call with the 1 second delay. Now sometimes we need to fetch multiple sets of data or make multiple kind of API calls like this, either simultaneously or in sequence. So let's start with the kind of in parallel one. Again, make API call of this value equals returns a promise. So let's say I have to kind of get an array of data sets. So maybe I have, once again, an array, and we'll just use the same values from before. So here are my data set IDs that I'm going to make API calls for. And let's say I want to do all that in parallel and get the final result. Well, there's a function for that that's very useful called promise.all. So promise.all takes an array of promises and kind of returns the end result of all those promises. And it does all that in parallel. So every promise just gets executed as soon as you create it. And when they're all done, you just get the result back. So this is a very easy way to do kind of parallel data. So what we'll do is we'll say promise.all. We'll take our array and just like turn it into the promises. We have the ID, and we're going to turn this into make API call ID. And at the end of this thing, we'll say dot then, and we'll console.log the result. And what you'll see, let's go ahead and put in our start point as well, just so we can see the time delay. If I run this in here, make API call. Need to spell that correctly. Let's try this one more time. So you start, you wait a second, and you see you get all 5 results back. So the reason that only took a second is because it all basically happened in parallel. So all these promises kind of ran as soon as we called them. They didn't wait for the other ones, and then we got the result at the end. So this is a really nice way to do, run promises in parallel. But what if you want to run promises in sequence? So maybe you don't want to like overload whatever kind of API endpoint you're calling, and you really want to do one at a time. Or even you might want to have the promise from before kind of influence the request for the promise after it or something like that. That would be kind of what we call sequential evaluation of these promises. This is where Array.reduce can come very much in handy, and so I'll show you how you do that. So instead of doing promise.all, what we're going to do is we're going to create a reduce function. So we'll say Array.reduce, and we know this is going to have some sort of function that's going to act as our reduction function. We also know it's going to have a seed. And so what I'm going to do is I'm actually going to start this with an empty promise. And this will become clear when we start to write our reduction function. So by default, we want to have a promise that just resolves a value. But what do we really want out of a reducer? We want to kind of get all these things to happen in sequence and get the final value. So I have my accumulation and I have my current value. And in this case, my current value will be an ID. So what I can actually do here is when you have a promise, remember, accumulator is a promise. I can call .then, and in the .then I can call a function that returns another promise. And it will kind of collapse those into a single promise, essentially. So in here, I can say, take my current value and make an API call out of it. Remember, my current value is the ID coming from here. And so this final thing will be kind of call this kind of sequential promises. And if I call sequential promises then and log this out, I should really just get the last value in this because I haven't been kind of storing the value of each promise. So if I come in here and run this function, you'll see a much longer delay until I get the value. So let's just add another console log statement to confirm like what's happening. So let's add in here that they're running it, just so we can see that they're running in sequence. We'll log out resolved call. We'll put in the ID. And so let's do that again just to see those delays. So start goes, it resolves the first call, then the second call, then the third call, then the fourth call, then the fifth call, right? So it all happens in sequence. Now in this case, I just ended up getting the last value. We could write some sort of thing in here to keep track of every single value, like if you wanted to concatenate these data sets together, etc. But in general, you can see now how the reduction function is not just about data transformation, or in this case it kind of is, but you can use it for all kinds of things like sequencing asynchronous requests together. So it's a very powerful function. When you kind of once you get comfortable with it, you can use it in a lot of different situations in some very kind of unique and interesting ways. So I hope this helps you leverage it the way that the way I've been able to leverage it.